Hi, everyone, and welcome to episode 70 of the Tick Bootcamp podcast. The title of today's interview is Bitten 1,000 Times, an interview with Nolan Fernandez. My name is Richard Johannesson.
And I'm Matt Sabatello.
Today's podcast guest is Nolan Fernandez. Nolan Fernandez is a 27-year-old microbiologist from Pittsfield, Massachusetts, who has been bitten by ticks over 1,000 times. He has spent many years researching ticks during his undergraduate and graduate educational experiences. As a result, he has many tips for avoiding ticks and protecting yourself from tick-borne illnesses. Nolan Fernandez also explores the topics of genetically modified mice, using DEET and permethrin, and the past use of ticks as bioweapons. Hey, Nolan Fernandez, and welcome to the program.
Hi, thank you for having me on.
Well, we're really blessed to have you today, Nolan, and we have a million questions that we want to ask you, but before we get to the 1 million tick disease related questions we have for you, we'd like you to please introduce yourself to our audience.
Okay, so I'm Nolan Fernandez. I have a master's in microbiology out of the University of Massachusetts. I also have an undergrad in microbiology out of UMass. And pretty much most of my work that I do, or most of the work that I did in my programs were tick related.
Nolan, where do you currently live?
Currently, I live in Pittsfield, Massachusetts.
The research that you did to ultimately acquire your bachelor's and master's degree in microbiology, did you do any research?
Yes, a lot of research.
And where did you do the research that ultimately resulted in you getting your degrees in microbiology?
So most of the research I did was on Cape Cod and Martha's Vineyard in Nantucket.
And what type of research did you do, and what kind of results did you see from the research that you were performing during the educational phase of your career?
So a lot of the research varied. So I did a lot of, for one summer straight, we did mammal trapping on Cape Cod, Martha's Vineyard, and Nantucket. That pretty much consisted of creating these grids in woods and pretty much trapping mice at different locations, drawing blood, collecting ticks, testing that blood and testing those ticks to see what diseases they had and what active infection the mice had. And pretty much we did that all summer long to kind of see what trends and how infection rates changed over a long span of, over a long period of time within the mouse population in those locations. That kind of introduced me to the whole tick research field. From there, I did some research with chemical repellencies, working with USDA, working with a colleague out of MIT who now is independent. And then also I worked with a bunch of boards of health doing pretty much collecting ticks and having an overall idea of active surveillance for infection rates in towns, just to get a better idea of infection rates in Massachusetts and in towns in Massachusetts.
What caused you to develop this passion for studying ticks and tick diseases?
So Dr. Stephen Rich was the professor that I worked under for both my undergrad and my graduate program. And he runs a business called Tick Report. And it's out of the Laboratory of Medical Zoology. Pretty much what we do is if someone gets bit by a tick, you can submit it to the lab. We'll test it. We'll let you know what the tick was carrying and what you could have been exposed to. And then there's different risk factors for, like if the tick is pretty much flat, your risk is very low. If the tick is fully engorged, your risk is going to be significantly higher. So working in that field and working pretty much hand in hand with a lot of the patients that, like a mother who her child got bit by a deer tick, the tick is fully engorged, she's freaking out. It was refreshing to be able to pretty much explain the process of like disease transmission, and kind of explain that not every tick is infected, and if a tick is infected, it's not necessarily mean that your child or whoever was bitten will get that disease. And it just kind of gives them like reassurance, and it's interesting how something so basic for me, who I'm like, it's basic information for me, but for them it pretty much gives them like a new perspective and kind of relief essentially. So that kind of got me into wanting to help out more, and like working there, you see that a lot of people kind of dismiss when they say they have a chronic Lyme disease and kind of don't really pay attention, and they kind of feel, I guess, alone. And I kind of want to fill in that gap a little bit and like help them understand the process and kind of just be another voice that they can talk to and get more like a science background to explain what is happening, kind of.
So Nolan, I understand during the course of the time you've been doing both your educational and your post-educational research, you've been bitten by ticks many times.
Yes.
How many different occasions have you been bitten by a tick?
I want to say at least 1,000 times. So every time I go out for research, if I don't get bit by a tick, then I wasn't doing my job right. So yes, I'm always in the field. I'm always getting exposed, but because I am actively checking, so I'll be walking, I'm like, all right, I'm going to just do a quick glance. I'll probably see like 3 or 4 on my pants. I'll brush them off. And then as soon as I get home, I make sure that I do a full body check. And then sometimes if I'm going to recycle clothes, I'll just make sure that I throw them in the dryer a little bit. So ticks are very sensitive to like dry heat. They dry out really fast. So that's why in like a very hot, like in the middle of a summer day when it's like really hot, they're not going to be out. They'll mostly be out like early morning when it's kind of dewy, or like later in the afternoon when the temperature drops. So kind of just knowing that you're like, if you're going to be in the woods, you're going to be exposed, assume that you're going to be exposed, and then just do your due diligence to do tick checks, because it's easy enough to do a tick check and kind of remove a tick. If it bites you, remove it right away. Or if you see it crawling around you, like get it off you, versus having to deal with treating the whatever bacterial infection that you get.
You've had experience at every stage of the tick disease experience, whether it be in the field, being bitten yourself, and also you've worked with people who have either acute Lyme disease or chronic Lyme disease.
Correct.
So now let's now walk back to the most important questions that we here at Tick Boot Camp are concerned about, and that is, do you believe that tick diseases are 100% preventable if you have the proper information and you take the proper steps to protect yourself?
I 100% agree with that. And if you want, there's a paper out of Harvard that was doing a study on Cape Cod, because Cape Cod in Massachusetts was the area that had the highest infection rate for like Lyme disease, anaplasmosis, babesiosis.
The Ferry study?
Yeah, so they're doing a study on education, like tick education, and it shows that, so pretty much on the Cape, rates of infection in humans have dropped significantly just because of the effort that they are doing towards educating people on tick prevention and just how to protect yourself from ticks, and pretty much just prevent that one tick bite that can change your life forever, essentially. So rates of infection within like the rodent population and the tick population is slightly increasing, but you see it decrease in human population versus other parts in the state where you still have increasing patients that are getting like Lyme or anaplasmosis, and that's because they don't have it. There's no effort for education, essentially.
So Nolan, let's talk about that. Let's walk it back now to the first step in the process that we would like you to focus on, which is tick avoidance. In order for a tick to ultimately make you sick, it has to find you, it has to grab you, it has to crawl on you, it has to bite you, it has to bite you for some period of time, and it then has to leave you. So let's go through that. Let's go through that process, Nolan, of ticks finding you in the first place, right? The tick avoidance element of this, or the tick protection element of this. What is your understanding about how ticks find someone that they would bite?
Okay, so I guess we'll go with we'll start off with deer ticks. So deer ticks are known as like the stalker predator ticks. What they do is they don't travel much. What they'll do is travel up and down like vegetation that they happen to fall off on when they were nymphs. And then if they molt into adults, they'll stay in that general area. They don't travel far, essentially, unlike amblyomma ticks that are or the lone star ticks that are actively seeking hosts. Deer ticks climb up vegetation and they kind of just stand there questing, which is they have like their two front legs out, just waiting for someone or something to walk by to grab onto. You'll trigger sometimes some of those if they feel vibrations or change in heat or CO2, then they'll become a little more active, and they'll, like, if they're down in like the lower vegetation, they'll quickly crawl up to the upper vegetation to make sure that they can kind of grab onto the person. Versus like lone star ticks, they're more aggressive. If they feel like a heat signature or that CO2, they'll actively crawl towards you and like get on you. And I was witness to that when I was doing a couple studies on Cape Cod, and we threw dry ice, and just that you just see the CO2 being released, and you look at the leaf litter and you see at least hundreds of ticks crawling towards the dry ice. And it was crazy. It almost looked like nanobots just crawling. I was shocked on the amount of lone star ticks I saw.
So Nolan, we know that there are 800 different species of ticks, and rather than going through one or two or three different species, let's talk in terms of what we know about ticks in general.
Okay.
What characteristics are common to ticks? Meaning, where should we avoid going so that we would not come in contact with a tick when we're out in the woods or the forest or out in the community in general?
So pretty much the rule of thumb is avoid any dense vegetation that will have high humidity. So regardless of any species, ticks will dry out. They're very sensitive to drying out. So they need to stay in an area that has like relative humidity of like at least 80%. Maybe a little bit lower, but like 80% is ideal for them. Say a mouse drops a tick in your front yard where you have like a bush. That tick will stay there, won't really move around, because at that point they'll be exposed because they'll be on your grass, your short-cut lawn, which they're not going to risk because the humidity is very low there. So they'll stay there. So if you brush up against that bush because you're trying to grab like a basketball or something down there, you can get exposed that way. And that's how a lot of people do get exposed, not out in the woods. Like let's say they go grab the newspaper, they brush up against their like hedges, and then they quickly get exposed. And they're like, well, I wasn't outside in the woods. How'd I get exposed? And it's because of that. They forget that pretty much your own backyard is ideal habitat for them, especially any dense vegetation. So I guess just be aware of any dense vegetation, like on your property, or if you're in the woods hiking and stuff, try to just stay on the middle of the trail and just do your tick checks. So
the first thing that we know about ticks is that they need to have a certain level of humidity, and they're going to stay in places where there's dense vegetation so they can be protected from drying out. Is that correct?
That is correct.
All right. Now, we also know that ticks need to have a blood meal, correct?
Yes.
So if there is wildlife in the locale where we're going to frequent, we should be aware of ticks, because if there are rodents or there are deer or there's some other wildlife population that will be a reservoir for the tick, it's likely there'll be ticks there as well.
Yes.
Nolan, is this a year-round problem, or is this just a seasonal problem in the summer times that people should be worried about this?
It's definitely a seasonal thing, because like during the winter, I'm from New England, so we get a lot of snow. So during the winter, the leaf litter kind of protects like any tick that is like right now is adult tick season. So I'm doing some collecting right now for a couple of contracts that I have. So what happens now is all the leaves have fallen. We got snow yesterday, but kind of melted away. But once like true snowfall hits, it kind of insulates the adult ticks that are actively searching for hosts right now. So things kind of die down a little bit because of the cold and because of they're covered with snow, and it kind of like a physical barrier from the ticks and us. But what happens is if you have a winter, like a warm winter with very little snow, they will come out again. So pretty much ticks are active around 40 degrees. Once it starts dropping below 40 degrees outside, ticks kind of, I don't want to say they don't freeze, but they kind of just don't really move. I've done a couple studies on like going out and trying to collect ticks at different temperatures. And yeah, pretty much once you hit that below 40 mark, you can go into like a very dense tick area where you're going to get covered in ticks and not get one on them. And then you go back when the temperature is 15 degrees or higher, and you'll be covered in ticks. So it is definitely temperature dependent as well.
So Nolan, we understand that you have experience with helping folks to protect their yards, protect the people who will be in their yards from coming in contact with ticks. What recommendations do you have for folks now in the fall and then in the spring and the winter to help them reduce the likelihood of coming in contact with a tick in their yard?
So I would definitely recommend, so like wood piles are a good source for mice, which are the vehicles for ticks. So if you have a huge wood pile that's not very well maintained and kind of just like abandoned, you'll have nesting mice in there during the winter. And then when spring comes around, that area is going to be like a red zone for ticks. Like if you go to pick up a log or something, there's going to be ticks everywhere. So I'd recommend either like covering that up or arranging it in a way that kind of deters mice from like wanting to hibernate in there. Also, like pretty much cleaning up any leaf litter, because leaf litter, even if you have short grass, you trim your grass, leaf litter does allow that high humidity that they need. So they kind of like ticks will like hide pretty much in that leaf litter. Also, pretty much just keeping your grass cut low, and then just maintaining a good barrier. Like if you have your lawn that abuts woods, kind of like clearing a nice path between that, between your lawn and the woods. If you have, I think it's like recommended to have like 3 feet. Even if you just cut everything down and just have like 3 feet of no vegetation in that greatly decreases your risk of ticks kind of coming over from the wooded area onto like your grass.
From a tick control perspective, you worked with the Virginia Military Institute to test a robot prototype to kill ticks in the field. Can you talk to us about that?
Yeah. So pretty much what it was almost looked like it was like a vehicle robot, and they had this cloth that was treated with permethrin, and what they had they used a guide wire that also had like hosing for CO2. And essentially what they would do is create the path they wanted the robot to follow, release some CO2. That CO2 kind of activated and made aggressive, I guess you can say, the ticks. And then what they would do is release the robot with the treated flag, pretty much drive around the trail that they created for it. Essentially what the project was, or the robot was, you'd have the ticks come towards the CO2, and then you have the robot drive over that with the permethrin-treated cloth and essentially kill any tick that comes into that vicinity.
What was the result of that testing? Was it a successful test?
It was a successful test for amblyomma ticks. So when we were doing it for deer ticks, because deer ticks' behavior is a little bit different, it was hard to get any like quantifiable data. I guess it was inconclusive for deer ticks, but because amblyomas are a little more motile and they're a little more aggressive, it works great for them. But because deer ticks are a little more stationary, it's not as ideal for them.
So you also did a study in the University of Massachusetts regarding pathogen distribution, and you collected fecal, blood, and tick samples from mice caught in the wild. Can you talk to us more about that study as well?
Yeah. So for that work, so for a summer straight, I think it was like 3 or 4 months. We did, every other week, we'd go to one location. We would trap mice, collect ticks off of them, test them to see what active infections they had. for what the ticks had. And then we drew blood from the mice to see what active infection they had at the time. And then if we caught a mouse over the 3 to 4 months that we did, we would see trends of the mouse having high antibodies for Lyme disease and then dropping, signifying that the infection kind of got cleared, and then it pick up like anaplasma and then kind of drop. So you kind of see those the interaction that of disease in the mouse and how fast they pick it up, clear it, and like what they get exposed to over the summer.
No, and are mice immune to Lyme and other tick diseases?
Symptomatically, yes. Subconsciously, that's why people hate mice, because throughout history of infectious diseases, mice have always been the reservoir for like the bubonic plague, Lyme disease now. So like the way, I guess, their genetics is, or the biology is, they just can harbor a lot of these diseases that make us sick, and it doesn't really affect them that much. Pretty much all the diseases found in the mice. The ticks are just the vehicle of transferring from the mouse to us. So if you do want to reduce the disease burden, I guess, in the environment, you have to look at the mice. You have to reduce the mouse population, essentially.
Nolan, what are your thoughts on genetically modifying the mouse to prevent the transmission of bacteria from the mouse to the tick, which then infects the human?
That is a good approach, but so when I was on Nantucket, I know MIT, Dr. Esfeld, wanted to create, or was working on creating, I think they were using CRISPR, which is pretty much, they wanted to attack the OspC gene in Borrelia, Lyme disease. So pretty much what they would do is make the mouse immune to OspC. So then if an infected tick would bite that mouse, it kind of just cleared the infection in the tick and protected the mouse. It's something that I think in the labs have shown that it works effectively. The only issue with that is I feel like it has to be more of a way to prevent ticks. Like I feel like tick bite would be a more effective way, because if you only attack one bacteria at a time, it's going to take forever. Because yes, you can reduce Lyme that way, but then you'll have anaplasmosis, babesiosis, viruses. There's so many other diseases out there that ticks transmit. But I think a more effective approach would be somehow genetically modifying mice to prevent against like a tick bite. If it picks up like antigens or something from the saliva, and kind of either killing the tick or kind of clearing all of the infection if possible.
No, there's a series on Netflix called Unnatural, where there are people in the field who go to communities and try to get their approval to go and release these genetically modified mice to test. And a lot of the residents in these communities have concerns. And even the scientists say, we don't know the potential outcome of what this can do to the community and to the animals. So are you concerned about potential unknown side effects of doing something like this with genetically modifying any organism or any mammal?
Yeah, especially if you're going to release it into the wild. You don't know what the consequences are down the road. Just because we want like instant gratification now, that we shouldn't just like go off of that. There has to be long-term studies. Because like even things that were approved like 10, 20, 30 years ago, we're just starting to see the side effects of that and like the consequences that those cause. So I am a little hesitant with like releasing stuff in the wild. I know that they've done some of that stuff with like gene drive in Brazil when the whole Zika outbreak occurred. But I think that there was like a stop in place that it wouldn't allow those genes to like go on. I think it was only able to go on for like two generations, and then it kind of just died like in nature. If there's something like that we can do, I would maybe be open to it, but we definitely have to do a lot more research to see what like the long-term effects would be.
I'll tell you, Nolan, that actually scares the heck out of me. And what I'm reminded of is when I read Chris Newby's book, Bitten, she strongly suggested that part of the reason why we're having the crisis that we're having is that there were tick experiments where ticks were altered and they were released into the wild as part of their weapons testing. So it seems to me that we may be making a bad problem worse by using the same tool that may have, or the same philosophy that may have created the crisis that we find ourselves in the middle of.
Yeah, that's totally possible.
What are your thoughts on using ticks as a potential bioweapon and that whole book, Bitten, and everything discussed in it?
I personally have not read that book, but it's definitely possible. I know tularemia, which is found in ticks, it's found in dog ticks, has been used as it is used as a bioweapon, especially like during the Cold War. I know the Russians were working on like weaponizing it. So I don't know if you're familiar with tularemia, but it's like pretty much the bacillus bacteria. It's one of those rod-shaped bacteria that causes like lesions, like really bad lesions. And when you get it, if the tick has it, you get bit by a tick, it like causes like open sores and everything. It can get pretty nasty. The worst part of it is if you inhale it. Like, I think it's like instant death essentially, because it just destroys your lungs. I know on Nantucket there was someone who was mowing their lawn and they ran over a rabbit, which rabbits are like the natural reservoir for that. They aerosolized it, breathed it in, and I think passed away a couple days later.
Nolan, we'd like to now take it to the next step of the analysis, which is rather than tick avoidance, let's talk about tick detection, because you have a lot of experience having detected over 1,000 ticks on you. Can you talk to us about the next level of protection that we should develop so that we don't ultimately get bitten by a tick, or we're not bitten by a tick long enough to ultimately get sick? Can you talk to us about your tick protection methods? Do you use any form of shield like permethrin or DEET? Have you studied those chemicals? And how do you check yourself for ticks after you're going out in the field trying to find ticks for your research?
So the two products that I definitely recommend are permethrin and DEET. So when I did a couple jobs with the USDA on repellencies, we used DEET, and pretty much anything above, as long as the active ingredient DEET is like 20% or higher, you're gonna be safe. Works super effective. Same thing with permethrin, super effective. Permethrin will actually kill the ticks versus DEET, where it just kind of deters them. As for what I use, because I want to collect as many ticks as possible, and kind of not deter them from me, I don't use anything. That being said, I've been doing research for 6 years, and just to show the power of tick checks, I've been bitten over 1,000 times easily, and I've never come down with everything. I haven't come down with anything. I always get my tick-borne panel blood test, and they always come back negative. And I haven't developed anything. So it just goes to show the power of a simple tick check. I know it's annoying sometimes. A lot of people are like, but I don't want to do it. It's like brushing your teeth. It's something that has to be done. Like, it can be tedious, but it has to be done. And once you get a system down, then it's easy.
So Nolan, I want to come back to your personal tick check procedure. Because you found over 1,000 ticks on your person, I'm really interested in what you do to specifically check yourself. What parts of your body do you check, and how do you do it?
Okay. So usually what I do, I have like a long mirror in my office. So usually what I do is I'll just take off all my clothes, just wear my underwear, and check my back, because the back is the hardest part. That you're like, most of the time you'll probably find ticks on your back. So I just make sure to get in the mirror and just kind of rotate my body and just make sure that I have nothing on my back, and then just look behind my legs. And then like while I'm in the shower, I just check my front side and like really tough to reach areas. I've never had ticks in my scalp. I know a lot of people do say that they find ticks in the scalp. I'll probably just recommend brushing your fingers through and just kind of scratching your head and see if you feel anything. But yeah, just using a mirror and just making sure that you cover every part of your body and just make sure that there's nothing. And you become familiar with your body over time. You'll be like, oh, that's a freckle, not a tick.
So, Nolan, we'd now like to take you to the next step, which is if you find a tick on you, what do you do?
So if you do find a tick on you and it's super engorged, so usually what I do with ticks, if I find them on me, I remove them. If they're flat, I don't really worry about it too much. If they're engorged or like partially fed, I'll put it in like a Ziploc bag and I'll label the date that I removed it. And I'll just keep it in a safe spot in case I come down with something like a month or 3 months down the road. I have that tick to, like, if I do want to test it or something, I know what that tick had. If you get rid of the tick, you get kind of rid of the evidence of what it was carrying. To just have it as like another reference. If you get sick, they don't know what it is. You end up testing the tick, has something, they test you for that, and you have it. I think that's something powerful.
So, Nolan, my understanding is that because you've been bitten by ticks so often, you actually have had a biological change. Can you share with our listeners how you've changed as a consequence of all the tick bites you've suffered?
Yes, I think over time, I just built some sort of immunity to the, not an immunity, a reaction to the saliva. Before, I would never feel a tick on me, and I would never feel a tick bite. But now, I get like almost like a burning sensation when ticks are crawling on me. So I know I have a tick on me, and when I get bit, it feels like a needle just like getting jabbed into my arm or leg or wherever I get bit. So that it helps me do a more thorough tick check because I know where they are.
Nolan, can you describe for our listeners the process of a tick spitting either a virus, a parasite, or a bacteria into someone it bites?
Sure. So I'll go with Lyme disease because it's the one that I understand the best. So you have the mouse that's infected with Lyme disease. You have the tick then bites that mouse, and as it feeds, it pretty much picks up a couple strands of Borrelia burgdorferi, which is the bacteria that causes Lyme. That bacteria then will adhere to the midgut of the tick, and the gene that allows them to do that is OSPA. So it kind of just cements them to the midgut so they don't kind of get digested. And they'll replicate there until the tick then bites another host or a human. So when the tick bites another host, the blood that starts getting into the midgut will activate the bacteria or Borrelia, and it pretty much goes through this transition from OSPA expression to OSPC expression, which is the motility genes in these bacteria, which allows them to then swim out of the midgut and then towards the salivary glands. And then once they're in the salivary glands, they'll pretty much swim out of the salivary gland into the active bite and then into the bloodstream. And then from the bloodstream, they'll move into like muscle tissue or wherever the blood takes them, essentially.
Now, Nolan, the amount of time it takes for a bacteria such as Lyme to be transferred to the host, and we're talking about human hosts in this case, will depend on where the bacteria is at the time that the tick bites you. So, for example, if the bacteria is in the spit glands of the tick, it could transfer that bacteria to the host more quickly than if it's in the midgut. Is that correct?
That is correct, yeah. So like, for example, so viruses, like Powassan virus, the virus that I studied, it's not internalized, I guess. It doesn't go into the midgut. It stays in the hypostomes. So like it stays like on the mouth parts of the tick. That's why for viruses, transmission rate is way lower. It's 15 minutes. It's up to 15 minutes because you have the tick will bite an infected mouse, pick up the infection on the actual mouth parts, and then when it bites another host, it will transfer it that way versus the more elaborate process of leaving the midgut, traveling to the salivary glands, and then out the salivary glands into the host.
Thank you for listening to the Tick Bootcamp interview with Nolan Fernandez. To our listeners, we have a call to action. First, if you'd like to know more about Nolan Fernandez and his tick-focused research, please visit his Instagram at tick_knowledge. Second, if you enjoyed this episode of the Tick Bootcamp podcast, please share it with your friends by using the social media buttons you see at the bottom of the post. Third, we here at Tick Bootcamp have created a Tick Bite blueprint that is inspired by the information that has been provided to us by past podcast guests. We urge you to visit our website at www.tickbootcamp.com to view the blueprint. We would appreciate it if you would contact us with any suggestions you have for improvements. Fourth, don't forget to subscribe to this podcast on iTunes, Google Play Music, or Spotify to get the automatic episode updates of our Tick Bootcamp podcast. And finally, we thank our listeners for your comments on our past podcast episodes. Please take a minute to leave us an honest review on iTunes, on Instagram, or on our website. We make it a point to read every single one of the reviews we get. Thank you for listening.